Hello, this is Professor Arai in chapter Identify Subproblems. Up till now, we covered two themes of problem solving. The first one was spatial organization. Under that theme, we learned how to draw a diagram and organize our information visually. The second theme was information organization. And under that theme, we learned how to do a guess and check method and how to organize our information using tables and lists. The third theme is called changing focus. And under this theme, we will learn our section today, which is the strategy of subproblems. So in this theme, instead of looking at the problem as one whole problem, you will dissect the problem into many subproblems. And the idea is if you can solve each subproblem by itself without being overwhelmed, you can finally find the final answer that you are looking for. For example, take example 1. If 3x minus 1 equals 17, what is the 2x minus 4? In this problem, you have to do the equation first, solve for x, and then you can plug in the x in this expression and find the value of this expression. So what you are basically doing, you are dissecting this problem into two subproblems. As I said, the first subproblem is solving the equation, solving for x, and the second subproblem is plugging in the x to find the value of this expression. This will be our theme throughout the whole chapter. Now, to make our job easier, we will create a list of questions for us. It will be like, what do we need to do next? What am I missing? How do I connect information 1 with information 2? These type of questions. And obviously, each problem, you can create your own subs of questions. The ultimate goal is always one, solve the whole problem. So let's look at example 2. 3 quarts of water are needed to water 1 square foot of lawn. How many gallons of water are needed to water a lawn that measures 30 feet by 60 feet? List the subproblems before answering the question. Now, my advice, try to do this question by yourself before you move on to the answer. Think, what questions do you need to ask yourself in order to solve this problem? So let's do this together. The first statement is saying 3 quarts of water are needed to water 1 square foot of lawn. I notice that I have several units, so maybe my focus should be on the units, but we'll see. The second statement is saying how many gallons of water are needed to water a lawn that measures 30 feet by 60 feet. So what do you notice? The first statement is given the amount of water in quarts. In the second statement, you have that the question is to find the amount of water in gallon. So the first or one of the subproblems that you need to figure out is how many quarts are in a gallon. The second problem is here. You are told that this amount of water can water 1 square foot of lawn. You are given an area. However, when you read the question, you find that you're not given an area, you're given dimensions of an area. So another sub-problem would be finding the area of this lawn before you start solving the problem. So let's look at some of these sub-problems questions. The first one is how many square feet are in the lawn? So because the lawn measures 30 feet by 60 feet, the area of the lawn will be 30 times 60, or 1,800 square feet. The second question, how many quarts are needed to water an entire lawn? So we will use the first statement. 1 square foot of lawn requires 3 quarts of water. So if 1 square foot of lawn requires 3 quarts of water, how many quarts of water are required to water 1,800 square feet? So what you need to do is you will multiply 3 times 1,800 and you will get 5,400 quarts of water. So you need 5,400 quarts of water to water that lawn. However, the question wasn't how many quarts, it was how many gallons. So the next sub-problem question is, how many quarts are in a gallon? So this is a fact. 4 quarts are in 1 gallon. Good. So we know the measurement conversion. The final step is to find the answer in gallon. So the final question is, how many gallons are needed to water the entire lawn? At this point, we know how much is the entire lawn from here. And we know how many quarts of water. We also know how many quarts of water do we need. So now you have to sum up or basically gather all the information that you found and solve this answer. The whole lawn needs 5,400 quarts. There are 4 quarts in a gallon. Dividing 5,400 quarts by 4 gives you 1,350 gallons of water to water the entire lawn. And again, we might be able to solve this problem by 2 sub-problem questions, or maybe none, but this is a very good strategy because it breaks down, it tells you exactly where is the gap that you're missing if you're missing part of this information. Let's see another example. Example 3. Paul went to buy a car. His friend Barbara Gain had bought the same car the day before. Barbara received a 30% discount on the car, which is listed at $15,000. The salesperson offered Paul the $15,000 car at 20% discount instead. When Paul protested, the salesperson offered an additional 10% off the 20% discount price. This offer satisfied Paul, and he bought the car, convinced that he had paid the same price as Barbara. Had he? Find the sub-problem lists first. So, what do we know? We know that Barbara bought the car that was listed at $15,000 after getting the 30% discount. We know that Paul got a 20% discount first, and then after that he got 10% discount. We need to know if Paul paid exactly the same price as Barbara or less or more. So let's look at our list. The first question you need to ask yourself, how much did Barbara pay for the car? She got 30% discount. How much did she actually pay? So 30% of the 15,000 is $4,500. So she got discount by this amount. That means she paid 15,000 minus $4,500, or she paid $10,500. So Barbara bought her car with this amount of money. Now Paul got 20% first. So let's see how much was that. 20% of 15,000 is 3,000. That means he paid 15,000 minus 3,000, or he paid $12,000. Now he protested this amount. So the salesperson gave him another 10%. So let's see how much is that 10%. So 10% of the $12,000 is 1,200. And since this is a discount, you'll take this amount out of what he paid. So you'll do 12,000 minus 1,200, and that will give you how much Paul has paid. So Paul paid 10,800. So the last question you'll ask yourself, who paid more and by how much? Paul paid 10,800. Barbara paid 10,500. That means Paul has paid more. He actually paid by $300 more. So for the next problem, the chocolate milk problem, you may solve it by using a combination of sub-problems and guess and check strategies. You could also choose to use algebra, but as any of those problems in this book, you're really trying to use the strategy rather than using algebra. So let's look at example 4. Adam is trying to make chocolate milk. He has made a 10% chocolate milk solution. This means that the solution is 10% chocolate and 90% milk. He has also made a 25% chocolate milk solution. Unfortunately, the 10% solution is too weak, and the 25% solution is way too chocolatey. He has a whole lot of 10% solution, but only 30 gallons of the 25% solution. How many gallons of the 10% solution should he add to the 25% solution to make a mixture that is 15% chocolate? Okay, that's a lot of percentage. So let's look at this problem again. He made the first solution, which is 10% chocolate milk. And they explained to us that 10% chocolate milk means 10% chocolate and 90% milk. He also made another solution, which is 25% chocolate milk. Again, it means 25% of it is chocolate and 75% of it is milk. He didn't like either of them. So he decided to mix both of them until he gets the percentage that he wants, which is the 15% chocolate. They also told us that he has 30 gallons of the 25% solution. So this is the cap for us. This is what he had. They didn't tell us how much he has of the 10% solution, meaning we can keep adding to this solution until we get our satisfied 15%. And that's why they told us we can use the guess and check strategy. So let's see how we can do it. So the first question you need to ask yourself, how much chocolate in the 30 gallon of the 25% solution is there? So 25% of the 30 is 7.5. This means 7.5 gallons are chocolate and the rest are milk. And we will need this information to start our table. So let's make a table. So this is our cap. We know that the amount of gallons of the 25% solution is 30 gallons. We also know that of those 30 gallons, 7.5 gallons of them is chocolate, pure chocolate. So this is pure chocolate, and this is the mix. And we need to keep adding from the 10% solution until we have 15%. Meaning each time we add gallons from the 10%, we need to figure out how much of it is chocolate, and then add the chocolate together, divided by the total number of gallons, and this way we can find the percentage. The percentage that we're looking for is the 15%. Hopefully it's clearer. Stay with me if it's not. Let's look at the table. So this is what he did. He started with the first row over here. So he had 30 gallons of the 25% solution. So again, 25 of the 30 is 7.5. So out of the 30, he has 7.5 gallons of chocolate. This is fixed, and that's why you see the numbers are fixed throughout the problem. These, on the other hand, are not fixed because they told us he has a lot of 10% solution. They didn't tell us how much. So we can actually keep adding and subtracting until we get the desired percentage. So let's try the first row. Let's say we take 20 gallons of the 10% solution. 10% of 20 is 2. That means out of the 20 gallons, there are 2 gallons of chocolate. So now let's mix the 10% with the 25% to see how much percentage of chocolate we will have. If you add the chocolate, the 2 gallons, and the 7.5, you will have 9.5 gallons of chocolate. This is your part. Now let's add the whole. You have 30 gallons, you have 20 gallons. 30 plus 20 is 50. So now to find the percentage, you will divide the parts by whole. So 9.5 divided by 50, it will give you 19%. This is not the desired percentage, so we need to make another guess. So the second guess he tried is 5 gallons. So one more time, this is the solution. That means 10% of this solution is chocolate. So 10% of 5 is 0.5. You add the chocolate to the chocolate. So 0.5 plus 7.5 is 8 gallons of chocolate. You add the whole. 5 gallons plus 30 gallons, that's 35 gallons. Once you have the whole and you have the part, to find the concentration, you'll divide chocolate by the whole and you'll get 22.9%. This is very high. This is not what we want. So, however, when he was rating, he rated the numbers he's doing. So he found that when he went down, the percentage went up. So maybe we shouldn't go down, we should go up. So the next guess he made was 30. So 10% of 30 is 3. Again, this is fixed. The chocolate will be 10.5. Total would be 60. Find the percentage and you'll find 17.5. So it went down, but not enough. So he adds more gallons of the 10% solution. He does the same thing and he gets 15.6, almost, right? So now he goes higher to make the percentage lower. However, when he went higher, the percentage became lower than 15%. That means he went too high. So instead of going from 50 to 100, now he's going from 50 to 60. So let's look at the last row. If you use 60 gallons of the 10% solution, 6 of the 60 will be chocolate because the chocolate concentration is 10%. So you will add the 6 gallons of chocolate to the 7.5. You will get 13.5 gallons of chocolate. This is the part. And the whole is the 60 gallons and the 30 gallons, which is 90 gallons. So part over wholes gives you 15%. And that was the actual percentage that he needs to get. That means he needed to add 60 gallons of the 10% chocolate solution with the 30 gallons of the 25 chocolate solution to get the exact desired percentage of chocolate he wants. And that's it. For this section, you have 7 questions. They all look similar to the examples in the lesson. Please pace your time, do them on time, and let me know if you're having any trouble. That's it. Take care.